Hey everybody, good morning, good afternoon, depending on where you're joining us from. And let's begin our demo. So hello and welcome to our CodeTuner demo for cloud. I'm happy to see you all here today and excited to share with you our new tool that is designed specifically for optimizing your cloud costs at the code level. In the next 20 minutes or so, I'll walk you through a demo of our latest cloud cost optimization tool. At the end, we have time reserved for a Q&A session. So please put all your questions in the chat, either here in Zoom or on LinkedIn, and we will address them at the end of this session. Before we jump into the tool, a few words about myself and the team behind CodeTuner. My name is Anastasia. I'm your host here today. I've been a part of product science team for over 2 years now, starting with our first product focused on mobile. I've led our performance analysis for enterprise clients, identifying optimization opportunities for them. And I also work closely with our developers to craft the tools that engineers truly appreciate. If you ever have questions about any of our tooling, feel free to contact me. Contact details will be available at the end of this presentation. So at Product Science, we're a diverse and dynamic team. We're passionate about enabling engineers to write the most efficient code. Our core technology captures everything that happens in your code, including any dependencies and all the parallel processes, that provides unique visibility and insights into any inefficiencies that you might have there. Just simply having this visibility into what really happens in your code brings clarity into what and how you can optimize, where to put your effort, and this really affects everything about your product. And the area where this impact is probably the most noticeable is in reducing cloud spending. So here is a quick sneak peek of where we're headed with this demo. We'll get to see how CodeTuner can show you everything related to your code and associated everything related to your cloud costs and how it is associated and related to your code. Before that, let's talk a little bit about the problem around cloud costs and why our technology is so efficient in solving it. Nowadays, cloud is essential for any business, yet for most of them, cloud costs are spinning out of control. Majority of low-hanging fruit of cloud cost optimization have been exhausted. Today, in order to cut these costs, companies are forced to either cut projects and features or to reduce the quality of their output. There are processes and techniques developed to address the cloud cost problem, yet it persists. And that is because we are not addressing the issue at its source, the code. Until now, cost management solutions have provided visibility into resource usage. They would recommend you to adjust usage of credits and promotions. The thing is that once you exhaust these options, there isn't much you can do further with the data that is available to you. You cannot just cut traffic because you need to use your servers to maintain functionality. So from that point, to make any optimization decision, you need to see where exactly these optimizations can be made. And for that, you eventually need to analyze the source of the problem, the code. And here, CodeTuner comes into play. What is so different about CodeTuner? Well, CodeTuner focuses on identifying the source of your cloud costs by capturing all cloud events on the code level. It reveals the costs associated for each call, including all the hidden costs. And we'll go into examples of the hidden costs throughout this demo. Other cloud cost optimization tools often lack this visibility, focusing on higher level architectural resource usage insights. And leading with that to incomplete and misinformed decisions. CodeTuner allows you to focus on the cloud cost savings that you can achieve directly by optimizing your code. So let me make it simple here. If cloud cost is an essential problem for your business, you've probably tried dozens of different tools and approaches to solve it. You got as much as you could from each of them, and now you're probably fighting for each % of your potential savings. Addressing and optimizing your code with the focus on cloud savings and spendings, can easily save you as much as 20% of your costs by targeting the issues that you previously had no visibility into. So now with that, let's explore what are these hidden costs that I mentioned and see how CodeTuner can help you understand and reduce them. In CodeTuner, you have three main views that uncover insights about your spendings on different levels. We'll go briefly over main features of each of them, and then go to see it all in action right in the tool. The most general is the dashboard view that you see here. It provides consolidated view of your spendings, and it helps you to quickly understand your most expensive costs. This is also the place where you will get all your notifications about spikes in your resource usage and any unexpected behavior. So this consolidated data that you can see here probably looks already somewhat familiar. And what really makes the difference is the next two views that provide detailed information in the context of these spendings, in the context of user sessions. So for each API endpoint, you can select a specific user session where this API was called. This gives you valuable insights into the sequence and context of API calls. When a real user is actually utilizing your product, you would get all of this recorded. So when you open a particular user session, you'll see details of all API calls within that session. You can see a breakdown by direct and indirect calls, where direct calls are straightforward API requests triggered synchronously by the user's action. The indirect calls, on the other hand, are triggered asynchronously by some other methods and, well, originally by some initial direct call. So the indirect calls normally create the most traffic and the biggest input in cloud spendings, while other tools usually lack visibility into which particular code events contributed into these largest spendings. Here is an example. On the screen, you now see the Cloud SQL query marked as a direct call. And on the other hand, you see Cloud Functions and calls to cloud storage that are marked as indirect, as they are triggered asynchronously by some other function executing on your server. So this view already gives you a better context of how exactly each of expensive APIs correlates with the user experience. Let's get a deeper understanding of this when everything is actually visualized on a trace file. So here you see the trace view. The trace view is the heart and soul of CodeTuner. It visualizes all code events executed during the user session and, well, contributing into your cloud costs. It also highlights all the asynchronous dependencies between them. So these yellow lines you see here, yeah, those are your asynchronous dependencies. CodeTuner allows you to capture all code events automatically with no extra effort on your side and no manual instrumentation. We use machine learning to find the sweet spot of capturing and showing everything that matters for cloud optimization, yet not to overwhelm the view and not to impact performance on its own. When an endpoint is called, you'd see a single direct call. Here it would be the post-trace call. In this example, the initial query that followed user's action trying to upload the trace here. So this call on its own is taking about just 1 millisecond to execute. But once it is done, once the endpoint is called, it can trigger additional events. Pretty much anything in general that can be SQL queries, serverless functions, storage requests. It could be AI model inferences. And all of these events have associated costs that are often missed in the endpoint cost calculation. So here you see how the post-trace query triggers a much larger chain of async events, including uploading data to Google Cloud Storage, Cloud Functions, some additional login, as well as some unrelated events that are happening in parallel. With other tools, you would see your spendings on the resource level. For example, you'll see that database or storage was accessed, but without the ability to relate this resource usage directly to the code, you operate in the dark and guess which of the code changes would actually impact your spendings. With CodeTuner capabilities, you know which specific method is responsible for any event, even if it is a tiniest spending, as well as you will see the logic behind its execution. So here you see that it's not just mentioning cloud functions or accessing the storage, but you can actually see here the names of methods and corresponding classes that you can find in your code and then do the optimization. So knowing this logic, yeah, you can really quickly optimize anything in your code by like reassessing what is happening there and then making your changes. Simply, if you just click on any method that you see on the trace file, you'll see this chain of events, and you would see what actually led to triggering the event that you clicked on. So with all this information, let's now see a journey of cloud cost optimization in CodeTuner itself. Here we are in the tool in CodeTuner. This is our UI, and we are back to the dashboard screen. So here you see the consolidated view of CPU and storage usage, as well as traffic and activity. For each of the endpoints that you see here, you also can see a breakdown by particular calls that are hitting these endpoints. For each endpoint and call, you can see CPU time, storage, traffic, and count, both as total amount and averaged per user session. You can also see them translated to your real costs. So one interesting observation here is that if you scroll down for, say, we chose the most expensive call that we have here, and we expand and keep scrolling, the first direct call that we see here, for that you would actually need to scroll pretty far. So what does it actually mean? Well, that means that the direct calls, the ones that you have most visibility into with traditional tools, would not be the longest or the most expensive ones. So that's just a fun observation explaining why hidden costs have so much potential. But then if you scroll back up for the indirect calls, for each of them, you would still have an original direct call that triggered it. So you can actually relate these events and see what was happening in the process and make your optimizations there. Now, this view, that we have here, it is a bird's eye view from which you can understand what are your most expensive endpoints and where to focus your attention if you want to analyze and investigate further. To actually do that, to analyze and investigate further, you can always select a user session. Let's do it here. And this leads us to our second view, the user session view. So in user session view, you see all the context of what was happening when a certain user was using your product and which endpoints were involved there. Why are we focusing on the user session at all? That is to ensure that optimizations that we make do not worsen user experience. After all, we want user experience to become better and faster, and to save our cloud spendings. But not at any point do we want to make it worse. So we constantly keep an eye on the user session and user experience. And from here, you can already, if you scroll down, tell a story of which calls were made, which endpoints were hit, in which sequence, and what was happening in the cloud. But to visualize this information, let's jump into the trace view. Here. So on the trace view that we've seen before, heart and soul of the tool, you see all of the methods that are executed in your code. We see them on their own threads. So if you scroll up and down, you see different parallel threads. The horizontal axis here corresponds to the time it took to execute a certain function. So you can clearly see the functions and the calls to hit in different endpoints here. See how, like I mentioned, that direct call was less than 1 millisecond. I actually know that because it's the tiniest one. So if I click outside, I can just click back on a method and it will reveal me the critical path that I mentioned. So if I zoom in just a little bit, I would clearly see that this is a Cloud function. Before that, in this path of async dependencies, there is another Cloud function. There is, let's zoom in here, a call to storage. And if we move all the way to the beginning of this chain, here, I'd easily find the direct call that was post traces call. So if you see on, you also can see like unrelated parallel events happening here on the trace file, but this is pretty much the path. This is the chain of events that happen. And again, in all this chain, you see that the direct call is taking the tiniest time, but what it actually triggers is a much larger chain of events that are using much more resources while executing. So again, hero chain looks like this. We started with a post traces event. Yeah, we wanted to upload a trace file to storage, which passed the data to Google Cloud, where, well, this data was processed. Now, notice how it just took me a couple of clicks. I just click on one method here to see this critical path. And our automatic instrumentation allowed me to see all the names of the methods involved in the process. So if I zoom in or hover over any of these methods, I would see which method it is, which is the method name, which class it came from, and how to find it in my own code base. By knowing these names of methods, both from my own code base and from any third-party libraries and frameworks, I can easily understand why and for what purpose each resource was used. And if you're interested to see maybe for a certain user action, how many events were eventually triggered and how much resources were overall used, one thing you can do is, again, get back to your direct call. Click on it, click here to switch to the forward. Click here to get the forward going connections. And what you will see will be pretty much the same view. You will start with the direct call. You will see calls to storage. You would see Cloud function invoked. But also, if you have more than one parallel processes, you will see all of them happening simultaneously. So if you parallelize any of your computations or do something else, you would actually see all of the branches that originated by one single user action. So this flow of understanding of what is actually happening in your code and how resources are used actually leads us to the real life example of a cloud inefficiency that we caught on our own backend. Now, let me quickly get back to the deck where we have a screenshot of one of very similar user sessions. It is just annotated there, so it's easier to follow which calls are which, where is Cloud function, where is a direct call, and where is everything else. So let me quickly get back to the demo, to the deck. And as promised, a real life example of an inefficiency that we caught on our backend that I just mentioned. And that comes from overusing our server when uploading data to be processed on Google Cloud. So what was happening before? There was a user's action that triggered the post trace request that itself started uploading data to our server. Once that was complete, the data was uploaded from our server to the cloud. Then on the cloud, it was processed. So this way, we were using 3 times the traffic of what we actually could be using. 1 time for uploading data to our server, one times for uploading data from the server to the cloud on the server side, and the same traffic on the cloud side. So we clearly overuse the traffic here, and by substituting the server uploading process with a request for Cloud Link to upload data directly to Google Cloud, we saved about 66% of traffic on this single operation. This is a pretty simple example, but what it really does, it provides a good illustration of how a trace file looks like, how you can actually tell a story of what was happening following user action, and how quickly you can identify and address the issue. This kind of inefficiency can happen to anybody, and realistically, it will keep happening. The point is not in avoiding inefficiencies, but in being able to catch and fix them quickly. Even if those inefficiencies happen in some ancient legacy code that it's hard for you to investigate, you can simply visualize it like that and understand what is happening there, why it's happening this way, and what you can do in a more optimal and efficient way. So this relation of specific methods from your code base to the associated spendings is what makes the cloud cost optimization so easy and straightforward. Now, I hope that by this point, you're as excited as I am about using CodeTuner, and let's stay in touch. You can hit my LinkedIn here or our email to set up everything you need to use CodeTuner for your team's needs. We have some time left for the questions now. Let me check. I think I see some coming in Zoom chat. I will also get a look into LinkedIn questions in a bit. If you haven't yet posted your questions, now is a perfect time to do so. Okay. Okay, so let's start with Zoom questions then. First question I see here, how do you see CodeTuner fitting into the company work cycle? Well, this is a great question because there are multiple ways really you can use CodeTuner, depending on your role and depending on your priorities. First of all, let me get back to the dashboard screen. So one of the most obvious ways to use CodeTuner would be whenever you get hit by a notification about any spike in your resource usage, and if you see any unusual behavior. If that happens, that's a direct indication of like, hey, we need to investigate this spike. And from this point, you can actually go and see where this spike came from and which methods were behaving differently, which code changes caused that spike in resource usage. So this is one way you can use it. The other way is just by investigating your most expensive calls. If you haven't been using our tool previously, there is a good chance that this chunk of optimizations that you can do on code level is there, and it was not addressed before. So if you just go over the most expensive endpoints and investigates what calls are made there, how they're made, from the code perspective, focusing on the resources used there, you would already find a lot of optimization opportunities there. So going backwards, investigating your code, the way it executes now, is a great way to use CodeTuner. So these are kind of like the two reactive ways of using CodeTuner in your cloud cost optimizations. The other way that we strongly recommend our clients to use is by using it in pre-production stage. So before you launch any code in production, you can run it on test environment, and maybe you will not get the exact final numbers of your spending, but you will be able to estimate those spendings, and you can actually see what they're looking like and see if anything misbehaves, if anything looks not as expected, if you are expected to spend more on certain areas of your product, then it makes sense to fix it even before it goes to production. So that's a great opportunity just to release better code, to spend less on cloud from the beginning. I hope this answers your question. There's 3 methods. 2 are reactive, 1 is in pre-production. Let me see. We have 2 more questions now. So, okay. How hard is an integration of such a solution with my project? Now, the integration is really instrumenting your code with our tool. And this is a one-time effort that you need to do. It normally requires several hours to do this instrumentation. Keep in mind that instrumentation is automatic, so it requires no manual instrumentation, no effort on maintaining it from your side. And it does cover everything from third-party libraries, frameworks, to your own code. Yeah, so it covers all your code base. It's done once, and maintaining it is really simple. There would be no extra effort needed once your code evolves. Instrumentation will evolve with it as well. So one time, about a couple hours. Now, okay, let's pass to the next question. What languages and cloud providers do you support? And if that is possible to roll that out on premises? Yeah, okay, so let's start with the languages. Right now, we already have released the version for JVM. We also have beta versions for .NET and for Node.js. Now, the approach in our team is really language agnostic. It's been like this from the very beginning, from our first tool that we released. And this is true for our core technology. So this really allows us to switch between different languages, to cover more languages really quickly and transition to them smoothly. We support Python. Go is in development now, and we are open to your further suggestion. If you are using something that I did not mention so far, just send us a message. Let us know that you're interested in it, and we'll make sure to prioritize it in our development roadmap. Now, as for the cloud providers and rolling on premises, that really doesn't make any difference for us. We work with all cloud providers, and of course, you can roll out our tooling on premises, yes. So let me get back to this last slide. If there are no more questions, if you have them, send them now. If not, I think we can wrap it up here. Again, it was great to host this webinar today. Great seeing you all. And please reach out to us with any questions. Happy to work with you guys. And let's connect. Let's connect. Let's stay in touch. Have a great day, everybody.